All right, this is Advent of Code, day 24. Here we go. Lobby layout. Your raft makes it to a tropical island. It turns out that the small crab was an excellent navigator. Make your way to this resort. Installing a new tile floor. The tiles are all hexagonal. They need to be arranged in a hex grid with a very specific color pattern. Not in the mood to wait, you offer to help figure out the pattern. The patterns are all white on one side and black on the other. They start with the white side facing up. The lobby is large enough to fit whatever pattern might need to appear there. The member of the renovation crew gives you a list of the tiles that need to be flipped over. Your puzzle input. Each line in the list identifies a single tile that needs to be flipped by giving a series of steps starting from a reference tile in the very center of the room. Every line starts from the same reference tile. Because the tiles are hexagonal, every tile is 6 neighbors. East, okay, E, S, E, S, W. Series of directions with no delimiters. Each time a tile is identified, it flips from white to black. Tiles might be flipped more than once. For example, a line like ESEW flips the tile immediately adjacent to the reference tile. East, southeast, west. A tile, okay. Northwest, west, southwest, east, east, got it? Okay. How many tiles are left with the black side up? Okay, cool. All right, so, okay, we can do this as basically, it's a shifted grid where A, B, C, D, E, F, east is 1, 0, west is 0, negative 1, 0, north, south, east is negative 1, 0, southwest is negative 1, negative 1, and then northeast is southeast is 0, negative 1. Northeast is 0, 1. Northwest is 1, 1. 1, negative 1. Stirs.each. Flipped chords. Yeah, flipped chords equals empty hash. Let's do z hash. So we'll be initialized to 0. Do steps. Okay. I equals 0 while I is less than steps.length. X equals 0, x equals 0, y equals 0. If steps I equals e, x plus equals 1, I plus equals 1. Else if steps I equals west, x minus equals 1, I plus equals 1. Else if steps I equals s, if steps I equals plus 1 equals east, else I plus equals 2, else if steps I equals n, else puts what? Exit. And then if it's east, so this is southeast, y minus equals 1, else minus y, so this is southwest, southwest, y minus equals 1, x minus equals 1. Southeast, northeast, so y plus equals 1. And then at the very end, flipped chords, x, y plus equals 1. Puts flipped chords, puts flipped chords dot count v mod 2 equals 1. $342. Nope. Okay. I made a mistake. EX1. 10. Oh, but 342. Puts flipped chords dot inspect. Values. Okay, yeah, so 10 are flipped once and 5 more flipped twice. Okay. Interesting. What is wrong? Else if steps I plus 1 equals west, else puts what? 3, exit, what 2, steps I plus 1 equals west. Okay, what? I guessed 342. Why is that not right? With the black side up. Puts flipped values dot sum. 514. Let's make sure this is correct. Let's see. Puts stir, or puts steps. Leads to X, Y. SEW, and WWSWE. Oh, okay. Northwest needs to be the opposite of northeast. So northeast needs to be the opposite of northwest. X plus equals 1. There we go. 438. 314? Wow, people dominated. All right, part 2. Tile floor in the lobby is meant to be a living art exhibit. Any black tile with 0. Every day, the tiles are all flipped according to the following rules. Oh my god. How many tiles will be black after 100 days? Any black tile with 0 or more than 2 black tiles immediately adjacent to it is flipped to white. Any white tile with exactly 2 black tiles immediately adjacent is flipped to black. Okay. Black equals flipped chords dot select kv v mod 2 equals 1 puts black dot inspect. Size. Okay, cool. Black tiles equals black dot keys. 100 times do new num black neighbors equals black tiles dot each do XY num black neighbors. This is a z hash x plus 1 y minus 1 north plus 1 y plus 1 south okay, and then new black tiles equals set dot new black tiles dot each black tiles plus num black neighbors dot keys that each do x y set dot new each do if black tiles dot include xy, else if num black neighbors x, num neighbors xy, if, all right, so if it's black with 0, if num neighbors equals 0, or num neighbors is greater than 2, it's flipped to white, else new black tiles is added xy. Any if num neighbors equals 2, black tiles equals new black tiles dot 2a, and then put black tiles dot count. 94. 85. Okay. Okay, this is really taking a while. Oh, puts n day n plus 1 black tiles dot count. $15, $12, $25, $14, $23. 60, 78. Okay, it's working. So now I just gotta wait. 438. That was my answer to part 1, right? Yep. Oh dear, this is taking a while. Why is this taking so long? Is this what takes so long? Black tiles. IRB require set x equals set dot new 1 2 x dot each do y puts y and num black neighbors a each do collection action each do. Wow, why is this taking so long? Oh, this is why. What's up, Eric? One second. Just one moment. Let's see. It's going fantastic, Eric. Oh, Mr. Person, did you win? Yes, you won. Woo. Whew. Okay, all right, finished. Eric, it's going great. You know, I'd been... Yes, Mr. Person, that's the Eric Wastel. Yeah, you might recognize it from this part of the website. Where are we? Personal stats. You know, a couple days ago, I had high hopes. I was like, oh man, I'm doing great. You know, a couple strong performances over the last couple days. I could really break through onto the top of the leaderboard, but I didn't do super well with the first line of the About page fame. I didn't do super well with linked lists. That was a bit of a struggle. Man, if I just hadn't put this 2A here, this day would have finished a lot faster. Probably would have, let's see, or I don't know, maybe 30 seconds, minute faster. Indenting a section of code wrong, brutal. That's what Python will do. Good for nothing. I hate Python. I initially didn't have my north, east, and southwest to be proper inverses of each other. That was tricky. Can get rid of these extra bits. Part 1. Part 2. Let's get rid of those dots. Whew. You couldn't find a pencil, and the pen was out of ink. .438 and 4038. Is that what my part 2 is? Yeah. All right, let's review the problem. Day 24, lobby layout. Your raft makes it to the tropical island. It turns out that the small crab was an excellent navigator. You make your way to the resort. As you enter the lobby, you discover a small problem. Whoa, Charmed to K29, thank you for the follow. Also, Hex 864. Hex 64, thank you for the follow. How's quarantine? Quarantine was great. I'm now rejoined with the rest of my family, so that's fun. Alrighty. As you enter the lobby, you discover a small problem. The floor is being renovated. You can't even reach the check-in desk until they've finished installing the new tile floor. The tiles are all hexagonal. They need to be arranged in a hex grid with a very specific color pattern. Not in the mood to wait, you offer to help figure out the pattern. The tiles are all white on one side and black on the other. They start with the white sides facing up. The lobby is large enough to fit whatever pattern might need to appear there. yes, I'm also glad that I didn't pound my head against a wall for an hour. Oh my god, the linked lists. A member of the renovation crew gives you a list of the tiles that need to be flipped over, your puzzle input. Each line in the list identifies a single tile that needs to be flipped by giving a series of steps starting from a reference tile in the very center of the room. Every line starts from the same reference tile. Because the tiles are hexagonal, each tile has 6 neighbors: east, southeast, southwest, west, northwest, northeast. Directions are given in your list, respectively as east, E, SE, SW, W, whatever. There are no delimiters. For example, E, SE, N, E, E identifies the tile that will land on if you start at the reference tile and then move one tile east, one tile southeast, one tile northeast, and one tile east. So that's east, east, southeast, northeast, east. Each time a tile is identified, it flips from white to black or from black to white. Great. So we get the tiles and we want to know how many tiles are black. So to store a hexagonal grid, you don't need like some crazy data structure. A hexagonal grid is just a regular array with slight offsets. Basically, if you have this, you can just shift it over. So like northwest of E is A and northeast of E is B, but you can just shift this over, and so now northwest of E is A and northeast of E is B, and then southwest of E would be down here, G, H, I. So you have these are your directions that get used. Boom. I think whatever I just wrote might be slightly different. Your diagonals can be, these are wrong, because the key point is that your northwest has to be the opposite of your southeast. So this needs to be 0, 1. Northwest has to be opposite of southeast, and north, yeah, so these work. So all we do is we have a set of flipped coordinates, which is a hash initialized with default values 0. No, these work. Or these don't match what I have here, so I'll just do that. Are you happy now? Flipped chords will just be a hash from coordinates to how many times they've been flipped. So then I just have an index into each stir, and at each point, if it's E, I increment the X location. If it's west, I decrement it, increase the index by 1. But then if it's southeast or southwest, I'll end up incrementing I by 2. And then yeah, when it's like southeast, I then also update. I like update Y, or if it's southwest, I update both. I basically just, in each of these branches, I add these coordinate updates. And then at the end, I increment how many times that coordinate has been flipped. And then I print out how many coordinates were flipped an odd number of times. So then for part 2, the lobby is complete. And we're now basically going to game of life with our lobby. Any black tile with 0 or more than 2, black tile with 2 or more, with 0 or more than 2 neighbors will be flipped to white. Any white tile will, with exactly 2 neighbors, will be flipped to black. So now I do this in a way, what day was that? Day 17 maybe, where we had like the 4D game of life. On that day, my approach was like keeping track of like the min X and Y coordinates that I've seen, and then iterating over X and Y in that area, counting how many neighbors it has. But someone pointed out a more convenient approach, or that like a slightly easier approach, is to basically just for each coordinate, each living cell, so every black tile, just keep track of every cell, how many neighbors it has, and then loop over those, because a black tile has to have at least 1 neighbor to stay black, and a white tile has to have at least 1 neighbor to become black. If something has no neighbors, it always dies. So we keep track of how many neighbors it has, count all those, and then we actually don't need to iterate over that. Dot each do k xy equals k. Oops. I think that works. 438, and so we loop over everything, count how many neighbors each tile has. Then for every tile that has some neighbors, it might be alive or dead. And so we loop over all of those. We get how many, x, y, num neighbors. That's a little cleaner. And then we're gonna have a set of the new black tiles. And so if that point was already black, then if it's 0 or 2, it stays, it becomes white, but otherwise it becomes black. And if it's white, and its neighbors is 2, it becomes black. And then we just update our black tiles. And then at the end, we just print out how many tiles we have. Yep. And using a set is much better than using an array. If you use an array, it's very slow. Specifically, this include call will be very slow. Yeah, so that is that. December 24th, 2020 solution. Why do I need a include call? This is checking whether or not that tile was originally black. So if it started as a black tile, then these rules apply. Well, yeah, because it has to linearly look through the array. So that becomes linear, and then it does that for every single black neighbor. So then, like, if I do 2a here, puts dot. So here I put a dot after each iteration, and let's put n. That's how fast it goes. But if I change this to a, it very quickly slows down. I'd set up the array, so that's the index into the array, but it's a tuple. And I don't know how big it'll be. Anyway, that is Advent of Code, day 24.